Support comes from the Missouri Forest Products Association, providing more than 41,000 jobs in the production of wood pallets, railroad ties, white oak barrels, hardwood floors, and more. Details at choosewood.com.
Welcome to St. Louis on the Air. I'm Sarah Fensky. On July 30th, the U.S. launched a van-sized robot rover into space. The rover is called Perseverance, and the goal is a touchdown on Mars by this coming February. For the first 90 days of any Mars mission, workers at NASA's Jet Propulsion Lab in Southern California switch over to a clock that keeps Martian time. And Raymond Arvidson, a professor of Earth and planetary sciences at Washington University, says that he's probably, quote, done more Mars time than anyone else on Earth. For him, Mars is an area of expertise and it's a passion. And he joins us today to talk about it. So, Ray Arvidson, welcome to the show.
Well, thank you for inviting me.
So you're such a Mars expert. What got you interested in space to begin with?
Oh, gosh, I grew up with Sputnik in the 50s, and then all the manned missions to get ready to go to the moon in the 60s. And that just seemed like a great frontier, so I thought, well, this is where I want to go. I either want to go into oceanography or exploring the planets, and it turned out to be the latter one, and it never looked back. It's been a lot of fun. And we're on the frontier of science.
And what led you to go the academic route to study Earth and planetary sciences rather than to want to be an astronaut yourself?
Really, I like to be involved with students. I love teaching. I like doing research. So it just seemed like when I was an undergraduate at Temple University in Philadelphia, I just thought, boy, this is the kind of environment that I would love to be in. And managed to get a job at Washington University.
And not only did you get a job at Washington University, which of course is such a great school, but you have been working on these Mars missions. You're basically living every little kid's dream. What was the first Mars mission that you got a chance to work on?
Oh, this goes back a long, long time, Sarah. So it was the Viking lander missions. The U.S. through NASA put 2 Viking landers on the surface of Mars in 1976 to explore the red planet and to celebrate the bicentennial. And they were designed to search for life. So we had a robotic arm dug into the soil, the regolith of Mars, put it into some instruments, didn't find any life at all because they were looking at the kind of modern sediments. And Mars is a really hostile place today.
And was that a big disappointment back in 76?
Well, you have to realize back in 1976, there was still being made maps that had canals on them on Mars, and they don't exist. It's a figment of imagination. So our knowledge was pretty poor. But having no results from the soil, that was kind of a downer, and it led to kind of a nadir in Mars exploration until the 90s. And then we sent orbiters looking down at the surface. Lo and behold, we found evidence for river channels totally dried lake beds, exploding volcanoes in the distant past, and that kind of raised the interest in Mars again. So now the missions that we have going to Mars, including Perseverance, which is our NASA large rover, but also a Chinese mission, and believe it or not, an orbiter was sent in July by the United Arab Emirates through a Japanese rocket. And the reason is, the more we look in the ancient rock record of Mars, the more it looks like this planet was warm and wet and Earth-like billions of years ago. And the question is whether or not life got started and evolved, and the evidence is locked in the rocks.
That's interesting. So there's a real renaissance of interest in this planet.
That's right. So there would have been a 4th launch called ExoMars from the European Space Agency working with the Russians, but European Space Agency is approximately a dozen countries, and they were hit with the pandemic, and trying to get all that organized and on schedule, they just couldn't. So that mission, which is a rover called ExoMars, will be delayed 2 years.
Well, even with that delay, the fact that there's 3 going on all at once, as you say, one from the United Arab Emirates, which is striking on its own. But is there a reason that all 3 of these would have chosen the exact, well, not exact, but very close timing in terms of launching and heading towards Mars?
Yeah, exactly. It has to do with what's called celestial mechanics, because what happens is you launch from the Earth, and you kick stage to get out of Earth's gravity, and then you go into orbit about the sun. And you have to do it in such a way that when you reach the Mars distance, which is 1.5 times the Earth's distance, Mars has to be there. And that only happens every 2 years with about a 2-week window. So
that does sound pretty important. You'd feel pretty bad if you missed that 2-week window.
Otherwise, it would be embarrassing, right? You completely missed the planet.
Yeah, let's hope that's not in the cards here. Does it seem pretty certain we're going to land on Mars?
Oh, yeah. The question is, can we land successfully? So the U.S. has been really good through NASA, and we've did 2 Viking landers, Spirit and Opportunity, Curiosity, which 3 rovers, and the Phoenix lander. So we've been pretty successful. The Russians tried when they were the Soviets, but they landed hard and broke up the spacecraft. And hopefully the Chinese rover and Perseverance will work and will explore this planet. It's a big planet. It has the surface area equivalent to the continents of the Earth, and it's really complicated and interesting, and was warm and wet early in geologic time.
Now, I understand you are actually the person who chose the landing site. Is that correct?
Oh, no, me and about 100 people.
Hey, I mean, that counts. I'd take credit for that.
This is done through a set of workshops where the planetary community gets together, and you go through all the possibilities and all the important points, pros, and also the negative points, cons associated with the site. So that was done by a group, and then really chosen in the end by NASA headquarters and the project management. But we're going to a place called Jezero Delta. It's in a crater that's an ancient asteroid impact crater on Mars, but it was once a lake, and there's a delta that extends into it that's bone dry today, but it's like the Mississippi Delta. So if you wanted to find evidence for organics and life, go off to the edge of the delta in the Mississippi area, and you'd find it. So likewise, we think landing and exploring this Jezero Delta would really maximize the chance of finding all the organic material and any life form residue kind of washed into the lake and deposited in the delta.
So this isn't just a matter of trying to find that safe landing place. You also want to find fertile ground for research once it lands. Exactly.
Safety is utmost, which means you're not going to land in the mountains and you're not going to land in really deep canyons. So you want to land on the plains because you come in at the top of the atmosphere at miles per second, and then you have to slow down and land at a few feet per second, and you have to land in such a place that it's pretty level, pretty flat, and doesn't have a lot of obstacles. But that's Jezero Crater, and then you just drive into the delta. So it should be really interesting.
So speaking of driving, I understand that part of what you also helped with was wheel design and path planning. How can you do those things from Earth? This all sounds so complicated for somebody who's on the outside looking in.
Well, it's kind of cars on Mars, right? So I was the deputy principal investigator for the 2 earlier rovers, Spirit and Opportunity, that both lasted way out of their warranty. But I developed a specialty called terramechanics, which is how the vehicle drives and interacts with the terrain, and helping the engineers, figure out, well, is this a safe place to go, or is it too sandy, or is it too hilly? There's the mission called Curiosity, which is a rover that landed in 2012 in Gale Crater. So I'm the embedded expert on what's called terramechanics. So it's roughly the same group of people working on Perseverance and Curiosity. It's actually the same rover design, but Perseverance has different equipment. So it's just, helping the missions kind of get started and making sure that they land safely and can drive into interesting places.
It's interesting thinking about cars on Mars. You told our producer it's almost eerie how similar Mars was to Earth. How so?
Oh, it's so exciting, to come into work after a drive of maybe 50, 60, 70 yards, and you see brand new terrain. It kind of gives you the goosebumps because it looks just like the deserts on Earth. There are ancient river deposits, there are ancient lake beds, there are volcanic deposits that have been eroded by wind. So Mars was really active early on, but being a small planet, it lost its magnetic field, the core froze, the atmosphere was largely blown away. So all those terrains are kind of preserved, and it makes it look kind of like the Mojave Desert in California.
Is there potentially a cautionary tale there for those of us who are enjoying life on Earth, that this could be our future?
Oh, I don't think so.
Okay, thank you. I needed to hear that.
No. But we do need to protect the Earth.
Of course.
Earth to me is number one. And really the reason we're exploring Mars, if you think about it, is to understand us, right? Mm-hmm. So did life get started and evolve on the red planet? And if so, how did it happen? It's going to play back to understanding life on the Earth. Also, what caused this massive collapse of the atmosphere early on Mars? And does the kind of physics and the chemistry of how that happened tell us about, climate on the Earth? Not that we're going to become Mars, right? There are other planets like Venus, holy moly, where it rains sulfuric acid and there's carbon dioxide in the atmosphere that's 90 times the pressure in your room at the atmosphere. It's so much CO2 that the greenhouse effects make the temperature of Venus warmer than you can make your oven. That's not going to happen to the Earth, but it's another planet to study where you bring the physics and the chemistry and the modeling back to better understand the Earth.
Well, you're talking about getting understanding of the Earth. I also hear people like Elon Musk who are out there saying, hey, we're going to eventually get 1 million people living on Mars. And he tries to make it sound like all of this is doable. Does it seem like there's any possibility of human life on Mars in the future?
It's doable, technically. I wouldn't go. It's an extreme environment. It is incredibly cold. And it has radiation from space that gets right down to the surface because there's no magnetic field and the atmosphere is very thin. I'd rather stay on the Earth. But I think there'll be scientific exploration of Mars that involves humans. If and when we discover evidence that the planet was truly habitable, maybe had ancient life, maybe even life in the deep subsurface now where it's still kind of an equant environment, I think it will be more like Antarctica. Which is for scientific exploration. And with the exception of Argentina and Chile, no country declares ownership of Antarctica. I just am not sure why you'd want to put 1 million people on a place that can easily kill you because it's so harsh. I think it's more for scientific exploration. Yeah,
I'm hearing a pretty convincing argument here. I'm not about ready to go sign up as much as I'm sure Elon Musk would love to get us all up there. So Perseverance, it's supposed to land by very early spring, or I guess that's March, maybe
February.
That's February. So that's still winter. But when will scientists actually be able to get all these things that Perseverance is going to be gathering? What timeline are we on for that?
Well, it lands in February, and then it takes about 2 weeks to check it out. It lands actually wheels down from what's called a sky crane. Believe it or not, this rocket with the rover underneath it gets to within about 50 yards of the surface, and then the rover is let down on cables, and then the cables are cut, and then the rocket goes off to the side. It's called the sky crane. And then it takes about a week to make sure everything's working, and then it starts driving. So the science happens right away, and they'll drive into locations where they're going to put the arm down on the surface, and the arm has a drill, and they'll acquire about 24 little rock cores, and they'll be stored on the surface for return to Earth. And the reason, Sarah, is you can do a whole lot more in laboratories on Earth to get at biosignatures and evidence for life than you can on the instruments on and in the rover, although they're very sophisticated. So those instruments will help figure out which cores to get and to keep, and then there'll be a subsequent mission, maybe in the next 10 years, to bring those cores back to Earth to get into the laboratories for detailed analysis.
Oh, they have to go back to get them, to bring them back here.
Yeah. What we've been trying to get what's called a Mars sample return all the way back to the 1970s, and it's always been pretty expensive and complicated. But the technology is here now, but we want to extend it out over roughly a decade, maybe less, to kind of pace out the cost. So the first idea is to get the samples, right, to get the cores, put them on the surface, and then there'll be a fetch rover later on, a separate mission that they're designing now, to get the cores, put them in the nose cone of an ascent rocket. That rocket goes into Mars orbit, probably rendezvous with a return spacecraft, which then comes back to Earth.
So that sounds really exciting. 10 years can be such a long time, though, to wait. Is it hard not to be impatient, thinking, hey, this thing is about to land. I want to get my hands on this stuff now?
The planetary sciences and mission involvement is all about patience. So the mission, the rover mission called Mars Exploration Rover with Spirit and Opportunity. Mm-hmm. They landed in 2004, and they found evidence for ancient water all over the place in 2 different locations. So they were very successful. And landed and worked way out of warranty. They were supposed to go for like 6 months, but Opportunity lasted until 2018.
Wow.
Way out of warranty. And we just lost it because of a big dust storm, because it was solar powered. Anyway, it took about 8 years to get those missions together and launched. So you have to have patience in this area.
Well, I hope we can all have that patience, because what you're describing here is really exciting, and it's going to just be very fascinating to find out what Perseverance finds and eventually what comes back. So, Ray Arvidson of Washington University, I want to thank you so much for joining us today.
Oh, thanks. This was fun.
And Ray, again, is a professor of Earth and Planetary Sciences right here at Washington University, and was helping with the Mars 2020, the Perseverance. This is St. Louis on the Air on St. Louis Public Radio. That's 90.7 KWMU.
Support comes from the Missouri Forest Products Association, providing more than 41,000 jobs in the production of wood pallets, railroad ties, white oak barrels, hardwood floors, and more. Details at choosewood.com.